In this video, we are going to talk about go over an example of a transformation of function problem. So it says write the given function as a sequence of transformations, y equals f of x. State the value of k if the transformation is not a reflection. And then state the effect of each transformation has on the graph. State the pointwise effect that each transformation has on the graph. Okay, so what we're going to do then is start with y equals f of x on here. So let me capture an image of this. Okay, so remember the 6 transformations that we talked about, right? They're right here. We can add k to f of x, replace x by x minus k, multiply f of x by a positive k, replace x by k times x where k is positive, and then multiply by minus 1, replace x by minus x. So what I want to do is just, and here are the corresponding function notations. What I want to do is just go through step by step and figure out which of these transformations have been applied, okay, to this function. All right, so first right here, you want to think about if I start with y equals f of x, and then which of these 6 transformations could I apply to get here. And now I like to go step by step on each one because I think that's important. Sometimes the order in which you apply these transformations matters, right? So you want to think about, hey, I want to start here at y equals f of x, and I want to end up here. And how I'm going to go step by step is with these 6 transformations. So if you look, right here, I have f of x, or f of x minus 3, right? So the one that looks most like is this one right here, okay? And so that's what I'm going to do. I'm going to replace f of x by x minus 3. Okay, so replace x by x minus 3, which I did. Okay, and you can see I'm a step closer. This second function here looks more like this one, right? In fact, the only thing that's missing is this minus 1, right? So then I want to ask myself, okay, what would the next transformation be, right? And you can see here I'm basically subtracting a 1 on the outside. So the one that this looks most like is this one right here, right? I'm adding, which is, you can think of subtraction as adding a negative, right, on the outside right here. And so that is going to be the next one. So y equals f of x minus 3 minus 1. So what I've done is add a negative 1 to the formula, right? That's what I've done. All right, so step by step, I started with y equals f of x, and I used some transformations, some of those 6 transformations, to get to this function right here. All right, so that's what you need to do to break this down. All right, and then here I have this already written out, right, as to what's going to happen. So you can see I started with y equals f of x. Then actually here I did it backwards, which is okay, right? Here I subtracted the 1 first, and then I replaced the x by x minus 3. In this particular problem, you can do that either way, okay? So I should have looked at this first. I had it done backwards, but again, that's okay on this one. Now, on some of them, the order in which you go is going to matter, all right? So next, what I'm going to think about is what effect did this have on the graph as a whole, right? Well, subtracting a 1 or adding a negative 1 to the graph is going to shift the entire graph down by 1, okay? And then replacing x by x minus 3, right? Here the k is 3. That's going to shift everything to the right 3 units. And again, you can see that, right, the effect that those have. right? This is going to shift the graph right if k is positive, left is k is negative, and then this is going to shift the graph vertically up if k is positive, down if k is negative. So, and then the key to working these problems, again, to me, is that you want to add k to each y value to know the pointwise effect, right? That each of those have here, okay? All right, so if we had a point on the graph, then we would know that we would add -1 to the y value and add 3 to the x value. All right, that's the pointwise effect that this transformation has. It would add -1 to the y and add 3 to the x. So if I go here and pick a particular function, y equals x squared, and I pick a couple of points on here, 0, 1, or 0, 0, and let's do 1, 1. All right, so to figure out where these points would go, then what I would do is follow the things that I had here. I would add -1 to the y, right, and then add 3 to the x to figure out where those points go. So the point 0, 0, right, I would add 3 to the x, right, so that would be 0 plus 3, and then I would subtract 1 from the y. And so that point would go here. I need to zoom out to see that. And then this point, 1, 1, I would add 3 to the x. So 1 plus 3 would be 4. And then subtract 1, right, from the 1, or add a -1, however you want to think about it. So 1 plus -1 would be 0. So that point would wind up right here. All right, and so we have y equals, and so the graph now, y equals x squared, if we did those two operations, if we replace x by x minus 3, we would get that. And if we subtract 1, right, we would get that. You can see that that goes right through those 2 points that got shifted around. So you know where the points go, right, and then you know basically where the graph goes, okay? On the Newton problems, they'll give you 2 graphs like this, and then you'll just kind of drag them over on the Newton problems, and then the graph will kind of automatically follow. So you won't have to do this graphing part out, right? All right, and that is it on this one.